All right, can everybody settle down and find a seat, please? Those of you that are over here, there are seats closer if you'd like, but I understand you may be spreading out, so whatever works. We are here tonight for the annual presentation from NASA headquarters. I would actually like to start with 30 seconds of historically important spaceflight trivia. 100 years ago today, Robert Goddard launched the first ever liquid-fueled rocket upon which everything we do in this room is based. So let's just be happy for that. With that, I will pass the ball to Louise Proctor, who was once my boss at LPI and is now my boss again, but as the director of the Planetary Science Division at NASA headquarters. And she will take off on this, and when we're done, we'll go to questions. Louise, take it away.
This on? Oh, now it's on. Okay, yes. I've been up here a few times, but not in this role, so could be interesting. Thank you all for being here tonight. As Walter mentioned, I'm the Planetary Science Division Director. Happy to see so many of you in the room. And actually, I can't really see you because the lights are really bright up here. But I think you're there. Hope you're there. So today I'm going to present some highlights and updates from NASA PSD and Brad Bailey, sitting here to my right, my lovely assistant Brad. He's the NASA Assistant Deputy Associate Administrator for Exploration, so we just call him Brad. But he's going to present some updates from SEO, which is our Exploration Science Strategy Integration Office. I have to move the slides. Right. Okay. Sorry. So as we've all seen over the past year, the world is changing, right? We've seen changes in technology, industry, geopolitics. At NASA, we are very ready to adapt, especially right now. And change can be difficult, right? But it's also an opportunity to learn, to improve, and to achieve even greater feats. No one does the things that we do. Opportunity is rarely found in the comfort of the way things have always been. And our new NASA administrator, Jared Isaacman, understands this well, and he has demonstrated that our charge extends beyond tradition. We must be ready to act swiftly on emerging challenges and cross-disciplinary opportunities. And within the Planetary Science Division, within the Science Mission Directorate, of which we are part, and NASA as a whole, we are innovating constantly, always looking for ways to launch and achieve more science at a lower cost. And tonight we're going to talk about some of that, especially Brad's going to talk about that. So this is the local PSD leadership. We've seen a lot of change over the past 2 years, including with me stepping into the role of PSD Director last April, so I just missed last year's LPSC, and my deputy, Charles Webb, did a fantastic job of stepping in for a few months. I'm incredibly thankful to my PSD leadership team. You can see them here, but they've been helping my transition, and also to the entire PSD team at headquarters. And despite all the recent changes, we're ready to meet the challenges of sustaining US global leadership in innovation and discovery. And I did want to note that quite a few of the team are here today, so I'm going to ask that anyone from headquarters and also the SEO team, perhaps you could just stand up and wave at everybody. Thank you, Brad. Yeah. That includes you. Thank you. So obviously we'll be here all week, and we've got a ton of NASA events. We'll show you a slide at the end about what some of those are. Please do come and chat to us. We are here to learn about all your exciting science endeavors. So the FY26 appropriated budget, I thought I'd just get that out of the way up front. So in January, Congress passed a minibus bill. They allocated $24.4 billion to NASA, $7.25 billion to SMD, right? So science has $7.25 billion, that is quite a lot. And $2.5 billion of that came to the Planetary Science Division. So this is the largest budget within SMD. And with these resources, we can continue to tackle the audacious questions that no one else really can take on, right? Our science portfolio right now is strategically designed to deliver the highest impact with the resources we have available. So the things we are supporting moving forward, missions in prime operation. So these are missions that have launched but have not yet completed their main purpose for being. So this is Lucy, Psyche, Clipper. They're all en route to their destinations. We have some instruments on partnered missions as well. I'll talk about those later. Missions in implementation. So these are missions that have been confirmed. We are building, we are testing them. So NEO-Surveyor and Dragonfly. And missions in development, Da Vinci and Veritas. Also, Mars Exploration Program, Planetary Defense Coordination Office, and of course, RNA. So these are all major efforts that we are still continuing as we move forward, budget permitting. I did want to note, though, we can't continue everything in the past. We had a fantastic appropriation from Congress, and we can continue almost everything that we have been doing. We're very excited about the funding that they have given us. However, we are about 200 million below where we were last year, and that means that not everything can continue forward or can continue forward in the same way. So we are having to make some hard strategic choices. Right now, we have, when Congress appropriates a budget for us, NASA puts in what's called an operating plan. And so that basically tells Congress how we plan to execute on that budget. And so that budget is working its way through the system right now. It will go to Congress, and they will have, I think, at least a couple of weeks to weigh in on that and see if they agree with our plans. So that is all underway. And until that happens, nothing that we are doing over the next year is final. So I just want to make that really clear because it's not obvious. This is just an amazing image, or several images of some of the samples that we've collected from the Mars sample return mission. MSR was cancelled in the most recent budget. We know it was a top priority in the most recent Planetary Decadal Survey, and at this time we are standing by for future budget guidance and direction from the agency as to how we might proceed, and we will share that information as soon as we have it. But at the moment, MSR is cancelled. I wanted to show this slide. This is regarding our extended mission. So one of the decisions that's been on hold since last year while we awaited budget certainty was the future of several of these missions. So our fleet of extended missions, 9 in total, continue to deliver important data and high-level science. This actually comprises about half of our planetary fleet. And several of these, you can see some of them are underlined in blue. I'm not sure how easy that is to see. But they went through a senior review process last year. That was in 2025. All were ranked highly for science, and you can download the full report online. The Lunar Reconnaissance Orbiter, I think that team has just been told they have been extended for a further 3 years. That's funded through the Lunar Discovery and Exploration Program, so that is in Brad's area. The decision on the others, so that's Mars Odyssey, Mars Reconnaissance Orbiter, Mars Science Lab and Curiosity, Juno and Maven will be communicated when the FY26 operation plan is finalised. Right now, we do anticipate they're likely to go forward, but it is likely that anything that does go forward will only be given a one-year extension at this time. There's just too much uncertainty in the budget at the moment. And then Mars 2020, also known as Perseverance, is currently going through the senior review process. Thank you, by the way, to those of you who've just been on that panel. And the decision on that will be communicated in due course. I know many of you asked me about New Frontiers 5. When is it coming out? So our current plan is to release New Frontiers 5, the AO, sometime in 2027, probably calendar year 2027. And the release of the AO will be preceded by a community announcement. The current plan, of course, as supported by the 26 budget. But we are still, that budget will inform further announcements about the AO parameters. So things like the availability of nuclear power, what will the cost cap be, and what will the target list be, okay? And some of that depends on the availability of nuclear power. So I know, a lot of you have been waiting a long time. I'm afraid you're going to have to wait a little bit longer, but please know that we do intend to release that AO as soon as we can in 27. Planetary research. Our planetary research programs, led by Kathleen van der Kayden, who is here in the audience, are also seeing many creative innovations as we meet today's challenges and try and achieve more science with the resources that we have. And as you all know only too well, our planetary research programs power a continuous cycle of exploration. They generate the questions that shape our missions, they create knowledge from our returned data, and they help us formulate new scientific questions to drive future discoveries by the agency, right? So it's this sort of, well, we've got this infinity loop here. The research mission cycle ensures that NASA's exploration builds strategically upon its established investments and on past findings. We are committed to supporting our research programs to the full extent possible with the resources we have available. I know that's been a bit of a challenge this year. I'm excited by the innovations we've seen as to how we manage those programs, and we need to ensure that we make the best strategic decisions and investments. I can't overemphasize the importance of RNA. I personally feel there's no point flying all these missions if we aren't going to look at the data afterwards, right? So that has been a critical part of our thinking as we've gone through the year. And as the director of RNA, Kathleen is going to be holding a research-focused town hall tomorrow at the lunchtime plenary, and I urge you to save all your burning research program-related questions for her. But here are a few high-level updates on ROSES. So ROSES 2023 is now fully closed. All decisions have been finalized. ROSES 2024 is very nearly complete. We have selected over 230 grants, and all reviews, I think, are done. We've just got a handful of selections that still need to be made. ROSES 25, as you know, was released a little bit later than normal. It was released in July. Since then, we have, actually that includes up to 6 planetary science program elements. They are listed here, and that includes the Omnibus Solar System Science, or S-cubed program. This features a rolling due date and short 5-page proposals. So this is something we're trying for the first time this year, trying to reduce the burden on the community. We still anticipate the potential release of additional elements in ROSES 25, including FINEST. I know a lot of you have been asking about that, and also PCEF, the Planetary Science Enabling Facilities. And looking ahead to ROSES 26, obviously we are not going to be releasing in February. We've blown through that, but we anticipate its release in July again. S-cubed will continue. Thank you for a lot of the feedback that you've been giving us. We're trying to incorporate that where we can. And we're also anticipating the release of a consolidated planetary technology program in ROSES 2026. For those of you familiar with our astrobiology program, this is part of RNA. The NASA Decadal Astrobiology Research and Exploration Strategy, as known as DARES initiative, is progressing well. And for those who've been following the development of DARES, the Task Force 2 has been selected. They are organising virtual community webinars on gap topics in astrobiology. Those recordings are posted, and the webinars occur on Wednesdays from noon to 4 p.m. Is it really 4 hours? Noon to 4 p.m. Wow. Oh, right, okay, it's 4 hours. Each week until March the 25th, so you've only got a couple more weeks to go on that, but they will be posted afterwards. And you can look at this QR code if you want more information about that. And the initial DARES draft slide deck will be shared at AbSciCon. That's going to happen in May of this year, so just in a couple of months. And that will be open for public comments in advance of the written final DARES document, which will be released at AGU in 2026. Another exciting change in PSD is our new PSD Data Services program. So this program includes the major activities within the planetary data ecosystem. So if you remember, we did a big review a few years ago of the ecosystem. And what this program does is it formalizes management of these efforts in order to increase the speed at which we can respond to growing data volumes, right, and the evolving needs of our science and exploration communities. This program is led by our Planetary Data Officer, Robin Ferguson, and it provides a foundation for all of our research and exploration activities. And so the goals of this program, as listed here, to ensure planetary science data are preserved, accessible and usable through the PDS and AstroMat, right, fueling innovation and exploration. And so the sub-goals to continuously evaluate and evolve planetary data and computing systems to meet the changing needs of our science and exploration community. And that includes data systems and computing infrastructure, including things like the high-end computing access, and provides capabilities to enable data analysis in the cloud. The team's also developing AI foundation models for the Moon and Mars and supporting the use of AI in planetary research. So we're really trying to get ahead of what we expect is going to be a huge amount of data coming down from Artemis and all the other missions that are going to the Moon and beyond. This program will also provide leadership in planetary data and software governance. We develop and implement standards that increase data interoperability and ease of use, right? It allows us to do gold standard science. And all of these activities are aimed at reducing barriers to data access and use and to accelerate data analysis so that all of you can spend more time on science. And this is something that we have really tried to ensure was well invested as we move forward. I did want to talk about the PSD analysis and assessment groups, also known as the AGS. As I communicated in a letter earlier this year, we're making a change to the relationship between PSD and these community-led planetary science analysis and assessment groups, so things like LEAG, MEPAG, OPAG, and so on. There are actually 8 of them. These groups are not federal advisory committees. They are not governed by the Federal Advisory Committee Act, known as FACA, which some of you are very familiar with, and some of you probably are not. In the past, however, they provided input to our Planetary Science Advisory Committee, known as the PAC. That committee did operate under FACA, and they provided input regarding scientific priorities. And in response to an executive order early last year which directed us to reduce the number of government advisory committees, the PAC and other similar SMD division-level FACA committees have been terminated. And so what that means is there is nowhere for our AGs to formally report up to in a formal manner. And also, we were told to reduce the number of advisory committees. And so, as a result, we have eliminated any formal support for those groups. Right? The community input of the AGs to PSD remains valuable, and so the main change is just financial support. We're not saying they're going away, we just cannot support them in the way that we have in the past. This provides an opportunity for the AGs to become independent, community-led bodies with the freedom to choose their own paths forward. And I'm committed to continuing two-way communication with the community in whatever way is the best path forward. So I do want to thank everyone, especially the AG chairs and their steering committees, for their inputs and feedback as we went through quite a long process last year to try and evaluate the future and what we might be able to support going forward. And I also want to thank the Lunar and Planetary Institute, Walter, Jamie, and your staff for their continued logistical support of the AGs over the last several years. So the AGs have helped build a really strong foundation for our field. I remember going to the first OPAG, I think it was 2008, something like that. They've been going a long time, they've been immensely valuable. So as they become self-organized entities, I'm very excited to see how the AGs will evolve and innovate to continue to help advance the planetary science landscape to one that is agile and responsive to NASA priorities and also welcoming to all. So science remains our compass as we chart new frontiers in the solar system, and it continues to drive why we explore. And we have a new administrator at the helm of NASA who is supportive of science and robotic exploration. And I want to take a few minutes now just to celebrate some recent achievements from across our mission portfolio. So our current planetary fleet, this is the fleet as per the current day, it's a phenomenal example of NASA's leadership in space and just how our missions can help also create the survival guide for human exploration. So this is providing essential knowledge so that humans can go and survive and thrive elsewhere in the solar system. And science drives why we explore. You all know this, of course. Our continued robotic discoveries help us learn about the Moon and Mars, our origins, and the whole solar system. And I don't have time to talk about all of the missions, but I'm going to hit a few highlights here before I pass on to Brad. So missions in prime operations. On the left, we have images of Lucy's flyby of the asteroid Donald Johanson that took place last April. They were about 600 miles from the surface. And this flyby was a full dress rehearsal for the Trojan asteroid encounters that will start in 2027 with the encounter of Eurybates in the L4 Trojan swarm. And the Donald Johanson flyby allowed the team to conduct a series of really dense observations, basically a full dress rehearsal as if they were at the first Trojan asteroid. So that helped them to figure out how to maximize data collection. As well as the images you see here from the Lucy Lorry instrument, they also collected data from the Ralph Color Imager and IR spectrometer and from the Lattès thermal IR spectrometer. So it was a really excellent opportunity for Lucy. Psyche is on track for its upcoming gravity assist at Mars in May as it continues its journey towards the metal-rich asteroid Psyche. It will arrive in 2029. Psyche will use the Mars flyby as an opportunity to rehearse conducting a satellite search that it will do actually when it approaches Psyche. So this is a really great opportunity to do this at a solid object. In addition, they're going to image Mars on approach at extremely high phase angles, that's low sun, to search for evidence of a hypothesized Phobos dust or debris ring and or a Deimos dust torus. So there could be some really exciting results just coming from something that we're doing just to get us there with lower fuel. On Clipper, the spacecraft continues to be healthy and well-behaved. It's well on its way towards the Jupiter system. It arrives in the system in 2030. And the Clipper undertook an Earth gravity assist in December that basically helps slingshot it towards Jupiter. So we are well on our way with all of these missions. Missions in formulation, so the teams are working hard on these missions to get them to the launch pad over the next couple of years, right? It's happening fast. So integration and testing is happening on both NEO Surveyor and Dragonfly. On the left, NEO Surveyor, in case you're not aware, will rapidly increase the rate of discovery of potentially hazardous asteroids with a diameter of 140 meters or larger. It has a goal of detecting and characterizing 2/3 of them in 5 years. So this is a major step in addressing the George E. Brown Near-Earth Object Survey goal, which was actually tasked in 2005, but to find at least 90% of these near-Earth objects 140 meters and larger within 15 years. So we're actually going to achieve that goal by the beginning of the next decade, I think early 2030s. And then on the right is Dragonfly. This is a mission to explore Titan. Titan, of course, is a complex carbon-rich ocean world, and Dragonfly is a rotorcraft that will fly from site to site on the surface. The atmosphere of Titan is perfect for flying a rotorcraft, and we'll actually be able to go much further with Dragonfly than even the furthest we've been with our Mars rovers, just because of the way we're doing this. This image on the right shows the spacecraft model testing that took place in the NASA Langley Transonic Dynamics Tunnel last year. It's the only facility in the world that can recreate the conditions that Dragonfly is going to face. And we were very lucky to actually go and see this out there. This is actually a full-length model. You can't see it from here, but it's only half the width. So they were just testing how do the rotors behave in sort of Titan conditions. And integration test activities started at APL, so they're ongoing. And this is a really complex mission, right? It's one of the most complex things we've ever done. But it's also hugely exciting. And we've still got a way to go before we get to the launch pad, but the technical work from the team is going exceptionally well as they move towards their 2028, July 28 launch date. Did want to talk about MAVEN. So as you've all likely heard, contact with our MAVEN spacecraft was lost late last year. On December the 4th, a fully successful contact occurred. Everything was fine. All subsystems on the spacecraft were operating nominally. No indications of problems whatsoever. However, our last communication was received on December the 6th. We just came out of a scheduled occultation where the spacecraft passed behind Mars, and no signal has been reported from the DSN since the end of that occultation. We have had, still have an ongoing radio science campaign that successfully recovered some fragments of telemetry during a several-hour period following the loss of signal, but no spacecraft telemetry or signal has been received since that time. Analysis of the radio science data indicate the spacecraft was rotating in an unexpected manner when it emerged from behind Mars. And the frequency of the tracking signal suggests that there's been a shift in MAVEN's orbit trajectory. So we continue to create timelines of possible events and identify likely root causes. The DSN continues to listen to signals from the spacecraft, and we've also pulled in other assets like the National Science Foundation's Green Bank Observatory, and even the Curiosity rover has pointed its camera up to look and see if it can find MAVEN. We've convened an anomaly review board to evaluate the recovery efforts and assess the probable state of the spacecraft and the likelihood of recovery. Just to, talk a little bit about what MAVEN has accomplished. MAVEN was in its third extended mission phase, and has spent over a decade in Mars orbit. It's provided a huge amount of information across a full solar cycle about how Mars transformed from a warm, water-rich world into the frozen desert world that it is today. A couple of key discoveries include confirmation of Mars's atmospheric loss mechanism, specifically that solar wind and UV light are the primary drivers of atmospheric escape at Mars. It's really important for understanding the Mars atmosphere. And also that Martian dust storms can loft water molecules to high altitudes where they are broken down and lost to space. So this is one way how Mars has lost its water. MAVEN also relays about 20% of the total Mars rover data volume and provides redundancy in our Mars relay service. I did want to take a moment just to celebrate the entire MAVEN team for all they've achieved and for their absolutely heroic efforts during the recent spacecraft recovery efforts. Really appreciate everything that you have done to Shannon and their team. Our other Mars missions are continuing to deliver great results. Mars Odyssey on the left. Mars Odyssey is celebrating 25 years in orbit later this year and continues to provide global observations using the Themis infrared and visible imaging system. The image shown here is a Themis thermal inertia map of Bonestell crater, highlighting variations in surface materials and rock abundance, and also revealing complex glacial landforms. So Themis observations have helped us identify areas where subsurface ice might be present on Mars, tremendously important. The Mars Reconnaissance Orbiter entered Mars orbit a mere 20 years ago this month and recently captured its 100,000th image with the HiRISE camera. This is a major milestone for the mission. I remember presentations from Alfred McEwen, the former HiRISE PI, when this was just an idea that he had. So it's incredible how just fantastic this camera's been. The image shown here highlights the Syrtis Major region, revealing surface textures and layered terrain at meter-scale resolution. Just think about that, meter-scale resolution on Mars. And over nearly 2 decades, HiRISE imagery has allowed us to track changes on the Martian surface, so dunes, landslides, seasonal processes. It's also helped to identify scientifically compelling targets and support landing site analysis for future missions. So it helped us land Curiosity and Perseverance safely and will help with future landed missions on Mars. Curiosity, the second in from the right, this is a NavCam image that shows the Curiosity rover investigating the boxwork terrain within Gale Crater's sulfate unit. So these are mineralized fracture networks that likely formed when groundwater moved through the subsurface and deposited minerals along fractures. And Curiosity is studying these using instruments like APXS and MALI to better understand the processes that formed them. And these structures provide important clues about ancient water circulation on Mars and the past habitable environments. And actually, Curiosity is finishing up in the boxworks now, and it's slowly making its way out to the next area of study. So really incredible images from Curiosity. And then Perseverance. You all heard last year about the potential biosignatures in Chelyabinsk Falls, and Amit talked about those also earlier today. I'm actually showing here an image from an area that, I apologize to any French people in the audience, Lac de Charme. A recently braided rock target there was called 8 Canodon, not French, pretty sure, revealing a breccia composed of fragments from multiple rock types, and in particular, close-up imaging with the Watson camera identified fragments that may be granitic in composition, suggesting more complex crustal processes on early Mars than previously understood. And this discovery is either, I'm sorry, I don't know if she has already presented them or if she's going to present, but Yang Liu is presenting results on this here at this conference, providing new insight into ancient Martian crust formation and its geologic diversity. So, granite on Mars. Truly astounding scientific results are continuing to come from analyses of the Bennu samples that are brought to Earth by OSIRIS-REx, conducted by the OREX team and facilitated by a fantastic team of curation scientists at JSC, and of course many wonderful international partners on the OREX science team. So these results are highlighting the extreme power and importance of sample return missions. I didn't really appreciate how important sample return was until I toured one of the labs at Goddard where they're doing the Bennu sample analysis. Bringing these pristine solar system materials to Earth for study in our laboratories, you just can't beat it, right, in space. We're not there yet. And these results are helping to redefine our understanding of materials that were likely delivered to Earth and other planets during the early solar system that may have helped seed life on Mars. And just to list a few of the major findings from papers over the last year, all 5 nuclear bases, right, letters of the genetic code, have been detected in the samples. 15 of the 20 amino acids used to build proteins, they're key to life on Earth. All the components needed to form RNA are present in the Bennu samples, including the first ever detection of glucose in an astromaterial. They discovered a polymer-like material never seen before in extraterrestrial materials, which could have provided chemical precursors that triggered life on Earth, and also detection of unusually high levels of supernova dust, pre-solar material, providing clues to where Bennu's parent body formed, so actually out in the far reaches of the solar system, and also evidence of dissolved salts, right? So it was a warm, wet world at one point, so possibly similar to brines that have been detected on things like Ceres and Enceladus. We've seen evaporites in meteorites before, but never a complete set of evaporites that preserve an evaporation process that could have lasted thousands of years or more. And so this is just a small sample of the exciting work that's been done on tiny pieces of our ancient solar system. Yeah, and what really amazes me is the amount of sample brought back is not much more than I'm holding in this cup of water right now. It's really astonishing what can be done with just a tiny sample. What else do we want to talk about? NASA, 3i Atlas discovery, right? So the NASA-funded Atlas telescope first reported observations of the third known interstellar object on July the 1st of last year, comet 3i Atlas. It's passing through the solar system still, but it passed closest approach to Earth was actually on the opposite side of the sun, closer to Mars, and that made it very difficult to observe from Earth. But no problem, because within SMD we have a lot of assets in space, and so we led a coordinated observation campaign for this interstellar visitor using spacecraft from the Planetary Division, Astrophysics Division, Helio Division, international and interagency partners, both in space and on the ground. Ground-based telescopes, of course, very important as well, including the Atlas telescope. And at least 20 spacecraft have successfully observed 3i to date. And I'm just showing here a handful of images and data from across the various SMD spacecraft. And our data so far are showing that 3i Atlas is unusual in some ways compared with the bulk of solar system comets. For example, it has a high CO2 production rate and high methanol abundance. There's one homegrown comet that seems to be higher in those areas, but almost every other comet we've looked at, I think every other comet we've looked at is not. So there's some mysteries to solve there. Still to come, some PSD mission data yet to be downlinked or fully processed, so we haven't got all the data yet. There's still some JWST and Hubble programs are ongoing. They're looking at the molecular fingerprints of this object. Juno may be able to return some data in March. And also there are long-duration ground-based observing campaigns that are beginning to bear fruit, and their results are beginning to appear in journals and as preprints. So it's quite a while before this object even leaves the solar system. And this is the third one we've discovered since 2016. So I think now we know what they look like, we know what their characteristics are. We're going to be finding a lot more. I just want to highlight some of the rising stars in the planetary science community. These are our 5 early career award winners from this year. So they were actually from the PSD Roses 24 call that was selected in 25. I guess it was last year, technically. And this is an annual program that's intended to help promising early career scientists play an increased and meaningful role in the planetary science community. And so these 5 individuals represent a great array of talent, enthusiasm, and promise as leaders in planetary science. Their projects span a wide range of topics: interplanetary dust particles, planetary defense, digital terrain model capabilities, Jupiter system science, and software development for gamma ray and neutron spectroscopy. So I just want to congratulate Projector, Tarek, Margaret, Ali, and Mauricio for winning their early career awards. And we're excited to see what you do next. Just want to, in my last couple of slides, more to come in 26. So I'll end up by mentioning a couple of anticipated major events for 2 of our international part-led missions later this year. First, we expect the JAXA Martian Moon Explorer, the MMX mission, to launch this fall. MMX is going to visit both of Mars's moons and will collect a sample of Phobos to bring back to Earth. We will be receiving a small amount of that sample here in, I think, 2031 is the current plan. We are contributing hardware. The Magane gamma ray spectrometer and the P-sampler sample acquisition instrument are both in Japan. They're getting integrated onto the spacecraft right now. They're doing testing at the moment. And we're also funding several participating scientists on this mission. And secondly, Bepi Colombo is in the final stages of its journey to Mercury orbit. So this will be the first time Mercury has been explored from the perspective of 2 separate spacecraft. There's a magnetospheric spinner spacecraft from JAXA, and then the main spacecraft comes from ESA. And they will reach orbit in the final months of this year. The 1-year nominal science mission will begin in the spring. And so we have a NASA-funded instrument, the Strophio instrument. It's part of the Serena instrument suite, and it's on the Mercury Planetary Orbiter. It is a novel neutral mass spectrometer for sampling Mercury's exosphere. And several US investigators are also part of the wider Bepi Colombo science team, and I think we just told them they were selected, so congratulations to you. So go MMX, go Bepi. And then just to finish my last slide, I just wanted to say a moment to thank you to the planetary science community. Without you working every day, every week, every month, every year, all our aspirations and plans would be for nothing. We know it's been a really tough year for many of you. There's been a lot of change, there's been a lot of uncertainty, especially for those of you who are early on in your careers. It's been quite a challenge. It seems to us at NASA headquarters that things are starting to settle down a bit. We do have an administrator who really cares about science and is very excited about the robotic exploration that we are doing of the solar system. It is essential that we work together in creative and innovative ways to work with the precious funds that we have available. And to celebrate one another's successes, and I'm very excited to be here. It's so great to actually come to a conference and see the end result, right? Sometimes it's easy to forget what we actually do, that we're exploring the solar system, and that is hard and it is amazing, right? What a privilege it is to do this work. So I want to say thank you to you all, and I am going to pass over to Brad, who I called my assistant. He's not my assistant, he's actually Joel's assistant. I was just joking earlier. But Brad is going to tell us more about how we are exploring the solar system, at least the inner part. Thank you, it's pretty straightforward.
Thank you, Louise. And can I start off by saying, wow, what an amazing time it is to be a lunar scientist. There is so much going on the moon right now. Let me back up. It is so amazing to be alive at this time. Out of curiosity, quick show of hands, who here remembers the last Apollo landing? Okay, great. Everybody in this room better raise their hand when you plan on seeing the next moon landing. So we are heavily embedded in everything lunar right now, and we are working incredibly close with our partners within ESDMD, STMD, SOMD to make sure that science is at the root of everything we're doing on the lunar surface. I was only given a short amount of time to talk today about the moon, so I clearly could not go through our entire lunar program just this evening, but I do hope there are lots of fun questions coming from this group. But what I have pulled together is just a list of some of the recent selections we've been making, just to show the progress that we are undertaking within SEO, which is the Exploration Science Strategy and Integration Office within the headquarters. The first is PRISM SALSA, Payloads Research Investigations from the Surface of the Moon, and SALSA is standalone landing site agnostic payloads. And so we made 3 selections, Amelia 3D, which is going to make 3D thermal maps of the lunar terrain around the landers. We've got LISTER, which is Lunar Instrumentation for Subsurface Thermal Exploration with Rapidity. Seiichi definitely gets an A for, maybe an F for acronyms. But LISTER is also Blue Ghost Mission 1 fame. You all may recall the video we showed at this last year showing LISTER, a pneumatic drill, drilling into the subsurface of the moon on Firefly's Blue Ghost Mission 1. So this will be the next iteration of LISTER, and we'll have it on the shelf ready to go at the opportune time. And then, of course, we have Selene there, site-agnostic energetic lunar ion and neutron environment, which will be the first to look at galactic cosmic rays and their interaction with the lunar regolith as neutrons and secondaries are coming off of the surface. We also made selections around the Lunar Terrain Vehicle. So we made 3 selections, 2 of which will be on the vehicle itself, and I'll explain the third one here in a second. But we have Ares, the Artemis Infrared Reflectance and Emission Spectrometer, which will be looking at mineralogy as well as volatiles from the lunar surface. And then we have the Microwave Active Passive Spectrometer, Lunar Maps. And that one joins together a spectrometer as well as a ground-penetrating radar to tell us about the density and subsurface structure in and around the lander. Now, the other one we made selection for here is the Ultra Compact Imaging Spectrometer, or USIS. And USIS is largely a rebuild from HVM Cubed, which was an imaging spectrometer on the Lunar Trailblazer mission that we unfortunately lost around this time last year. However, we are also in negotiations and talks with the UK Space Agency to have them contribute another lunar thermal mapper, and together we will send those out on a CLPS task order for an orbital deployment of these payloads and get the data set that we were really hoping to get from Lunar Trailblazer. So we were excited for all of those selections. We also selected Artemis quotes 4, unquote, deployed instruments. We have the South Pole Seismic Station from Dr. Mark Panning, which is a very similar build to the Farside Seismic Suite, which is a CLPS delivery. And we also have DUSTER, which is Dust and Plasma Environment Surveyor with Zhu Wang from Colorado Boulder. So we're really excited to have those deployed instruments in the queue and ready to go as soon as possible. Also to note is, I think these are slightly out of order. We even tried to put them in order. Amanda's shaking her head at me, but that's not it. But we are making all these selections still to be made in 2026. We have PRISM 4, which is Payloads and Research Investigations from the Surface of the Moon. Recall that the PRISM line is the primary way that the Science Mission Directorate manifests CLPS deliveries, and PRISM is our PI-led investigation that answer significant scientific questions from decadals, from Moon to Mars objectives, et cetera. And for PRISM 4, we are planning to make 2 selections for this year and turn PRISM into an every other year solicitation. We've listened to you all. We know we are flooding your inboxes with opportunities and solicitations. And so we're trying to release some of that proposal pressure on you all. So PRISM will be offered every other year, and we'll be making multiple selections from each call moving forward. We also have the Artemis quote 3 unquote, participating scientist program. We're expecting to make awards on that shortly. We are also moving forward to select the next CLPS CT4 vendor. On board that CLPS CT4 delivery is the Australian rover, a NIRVIS. I'm sure most of you, if not all of you, are familiar with NIRVIS, infrared spectrometer and visible spectrometer. MSOLO, mass spectrometer, SCALPS, a descent plume surface interaction observation, LRA, small retroreflectors, only about 20 grams, about this big, but can be lased from lunar orbit. And then LV-RAD, it's a radiation sensor from Korea. We also have Sanctuary on there, which is a time capsule contribution from CNES and Canada. CNES, France and Canada. Let's see. Also this year, we're expected to do CLPS CP32. I'm going to select that vendor, and that is going to deliver DIMPLE, which is going to INA. And we also are going to do the Lunar Terrain Vehicle Project Scientist, as well as the Lunar Mapping Program Awards. So that said, hopefully you can see that there is a lot going on this year. And to drive home that fact even further, here are a list of upcoming CLPS launches scheduled for 2026. The first is Blue Origin's Mark 1 serial number 1. And there you see the picture of it on the far left. It's in Chamber A at JSC, about to undergo TVAC testing. My understanding is they closed the doors this morning. They're undergoing a test readiness review this afternoon, and hopefully they'll start pumping down the chamber this evening, as long as the TRR went well. We are expecting to see that go no earlier than April of this year, but it is next on our list. And you may also see a little friend in that upper left corner. That little friend is Viper. Viper is looking at this because they have a keen interest on that mission being successful. So Mark 1 serial number 1 has SCALPS, again, plume surface interaction investigation, as well as a small LRA on board. But in particular, we have also contracted with Blue Origin and Eclipse Fashion to deliver Viper on Mark 1 serial number 2 at the end of 2027. Now, the contract was actually stood up such that we gave them a small amount of money up front to show how they, to basically land successfully with Mark 1 serial 1, and also design an offloading system for Viper to get off of this tall lander. Now, Mark 1s are about 8 meters up, so we have to figure out how to get Viper from 8 meters down onto the surface safely. But once they have demonstrated and successfully landed on the surface, and they've designed that offloading system, then we will turn on the second half of the contract for them to actually deliver Viper to the surface. So again, yeah. Who is that? Is that Clive Neal's clapping? I suspect it is. And so we're really excited for Mark 1 serial 1 to go, not only because it is a demonstration of a 3 metric tons to the surface capability for CLPS, but also we are really excited for it to go so that we can see Viper get to the surface and get that incredible data set for us. Next mission in line is Astrobotic Griffin Mission 1. That is going to carry a commercial rover, the FLIP rover, and it's expected to go no earlier than July 2026. After that, we have Intuitive Machines IM3 going to Reiner Gamma, which is going to deliver the first PRISM payload that was selected back in 2021, and again, going to Reiner Gamma. And then Firefly Blue Ghost Mission 2 is going to do a couple of things. There on top, you see the lander itself. It's going to go to the lunar far side. This is a collaboration with the Department of Energy and NASA to deliver Lucy Night, which is a far side, it's a far side radio observatory to peer back into the dark ages. And so taking first of its kind measurements from the lunar surface, we're really excited to see that one go. The thing that's in the middle there is Lunar Pathfinder, and that is a Surrey satellite / ESA comm relay satellite that they're going to be delivering into orbit. And then the bottom half there is Elytra Dark, which is a kind of like a tug and communications relay itself. So we're really excited to see Blue Ghost Mission 2 go. The last thing I wanted to talk about was Artemis 2 and the science we're going to do from that. many of you have heard about Artemis 2 and Artemis and recent announcements around Artemis 3 being has changed from being a lunar lander with crew over to being a lunar orbit mission, showing docking to either one or both of the HLS providers. And then from there, Artemis 4 and 5 will be the first 2 landings in 2028 with crew. But of course, we've got Artemis 2 going here in the very near future. Just at the end of last week, we had the FRR that was passed successfully, and so we're expecting to see that launch go on October 1st is when the first opportunity for Artemis 2 is. And so I'm not going to talk too much more about the missions tonight. However, there is a fireside chat with Lori Glaze. Many of you recall Lori Glaze from her time as director of PSD and her standing in this very place in many, many years. And so that is Wednesday, I think it's 11:45, 11. Yeah, it's on your thing. You can look it up. And so, but that will be a wonderful fireside chat with Joel Kearns and Jake Bleacher, and I'm not sure if I can say myself if it's wonderful, but I will be there as well. And so we'll be talking about Artemis 2, Artemis 3, and then general plans forward and how science and exploration are working closely together. Anyway, coming back to Artemis 2, we have a really nice science campaign for Artemis 2. Remember, it is out and back. It goes out, orbits around the far side of the moon, then comes back. And we have on there ALOC, which is the Artemis Lunar Observation Campaign, where the crew is going to be using their own eyes, video, cameras to look out and look at the geological terrain as they're passing underneath it. They aren't super close. They're much further away than Apollo was, but when they're going to be looking out the window, it's about as big, the moon's going to be about as big as holding a basketball at the end of your arm. So that's how close they will be on closest approach. So ALOC, they're also going to be looking for impact flashes through that ALOC process, et cetera. We've got a space biology payload called Avatar on there, which is basically looking at tissue responses from with regards to exposure to the lunar environment. There are a number of other subsystems that are being tested on Artemis 2. We are also into basically looking at how the operations work. How do we work with crew? How do we work with the science evaluation room or the SIR here in conjunction with the mission control? How are we also using the SMOR, the science mission operations room, which is kind of the back room to the back room? And so we're really looking forward to Artemis telling us all that we can do for Artemis 3 and beyond in terms of operations. So I think that's my last slide, and with that, I'll turn it back to Louise. Is this for you? Yeah. Okay, thank you.
Can I have the... yeah, just wanted to draw your attention to some of the many NASA events that are going on this week. They are on your calendar, but please do attend as many of those as you can and come say hi to us. And with that, before we get into the questions, I just want to say we have some NASA calendars up here. They are coveted objects. They're in very short supply, and we thought that if people ask us nice questions, maybe we'll give you a calendar. Okay? So you can decide. All right, Walter, over to you. Thanks, Brad.
Okay. Okay, I will invite people to come to the various microphones, and when I call on you, be sure to identify yourself by name and institution. For those of you that are over here in the far right side of the area, what would be Waterway 6, if you want to ask a question, please come to one of these mics, because I can't look in every direction at once, and I'm frankly kind of blinded by the lights. So we'll start right here.
Hi, Mark DiBiase with DiBiase Consulting.
Hello.
On the New Frontiers AO, would it be limited to certain things of areas of interest, or would it be wide open?
New Frontiers is never wide open. The last decadals have always proposed a list, and we had the CAPS, the National Academy's CAPS committee, look at that list for New Frontiers 5 once we realized that we were not going to be able to release it as early as we'd hoped. So we have the CAPS report, and we are looking at the list of things within that report to decide, do we do all of them? One thing we don't want to do is, if we have programmatic reasons why we wouldn't pick something on there, we don't want to make the community go through the whole effort of putting a proposal in to do that. So there are a couple of things we're looking at, and whether or not nuclear power is available is another thing that will inform what is on that list.
Okay, thank you for the update on this. Good presentation.
Thank you.
Jim Head.
Jim.
Jim Head, Brown University. Louise, I think I can speak for the community in thanking you for stepping into leadership position in these really turbulent times.
Thank you.
And giving us a vision.
Well, it's an amazing team at headquarters. Thank you, Jim, but it really is an incredible team. I am very, very lucky to work with them, and they're all sitting there blushing now. Thank you.
Next microphone. I can't see everybody, so I'm just going to have to point at microphones.
Can I go next?
Okay, thank you. Louise, I just wanted to thank you for giving a shout out and pointing out the new 3I Atlas results. And I wanted to amend your list is that the SPHERE-X spacecraft, the NASA Astrophysics Mid-X, is observing it now.
Right now,
And we're
as we
observing
speak.
it through the first week of April.
Excellent. And what are they looking for in particular?
Everything.
Everything.
Dust,
Okay.
gas. We'll tell you how the object, most likely the water gas production is going to fall off a lot, but we're going to still see a lot of CO and methane and CO2 because that's what's underneath the depleted mantle surface.
Excellent. Thank you very much.
Okay, we'll come back to I'm just going to use them by numbers. Microphone number 2.
Okay, hi, Amanda Hendricks, Planetary Science Institute.
Oh, yeah. Sorry, I didn't even see that microphone. It's really hard to see. Hi, Amanda.
Let's see, I know that you're still working on your ops or spend plan for 26, but can you give us some idea of how much of the PSD budget will go to RNA?
It will be, well, actually, we don't know yet for sure, right? So we're still working the details of that. We do expect it to be higher than it was in 25.
Okay, will that include the STRIDE program?
It will not include the STRIDE program. So I'm looking at Kathleen here, but she will give you more information tomorrow, I think.
Okay,
Yeah.
thank you.
Okay, microphone 3.
Yes, Roger Weens, Purdue University. Jim had already said thank you to you, but I wanted just to say thank you for everyone who's been in this position for not stepping down and leaving us in the lurch. But my question has to do with the Discovery mission line, which I don't think I heard about much in your talk. Will there be any new AOs for Discovery in the future, and what about the current ones?
Yeah, thank you. So the Discovery program is immensely important to us, and of course the last, I think, 3 decadal surveys have also called out its importance. So we have been able to, we are hoping to move forward with at least the last 2 selections that were made under Discovery. They've been in a bit of a holding pattern because of funding issues as we came out of the pandemic. But we are hoping to continue those missions, of course, op plan pending. The next AO, I think, is also what you're asking about. At this time, we are planning to release the New Frontiers 5AO as the next AO, and then Discovery will be after that. It is likely to be towards the end of the decade, certainly no earlier than 28, maybe later. But it's still a very important program to us.
Okay, microphone 4, Clive.
Yes, Clive Neal, University of Notre Dame, and
Remember, your calendar is at stake here, Clive.
I'm not going to get a calendar. I already know.
Yeah, I figured.
It's all right. JAXA has sent me one instead, so it's fine.
We'll take it back.
I have a question for Brad and a plea to Louise. And I'll start with the plea, is that please can we open up LDAP and LMAP to resource characterization. Because when I've applied to LDAP, I've been told discouraged because we do science, we don't do prospecting. And I would really like to open that up because there is a need, a data gap in the architecture definition document for resource characterization. And this seems to be an easy fix to start using the data we have to fill that gap. And I put that plea out there. So that's not a question, it's just a plea.
We can certainly look at that.
Thank you very much, because I keep asking where do we go for resource prospecting at NASA, and nobody can tell me. So, and the question for Brad is, thank you for getting Viper on its way to the moon, a ride to the moon. Thank you, Joel. Thank you, SEO. Thank you. Now, my question comes to the funding of the science and engineering teams, because without them, getting Viper to the moon is going to be pretty pointless. So how are you funding them through the time till they launch, and then so they can ramp up to do the mission that they were put together to do, and how is that working?
Sure, thanks, Clive. It was a long road to get here, so thank you for your thanks. And so we do have a budget available for Viper in operations and the science team. Right now, we are still working with Ames and Johnson on what the end state is for that Viper budget. We absolutely recognize the need for science team for real-time traverse planning based on data as it's coming in, et cetera. We recognize that, Viper has a limited time on surface, and we want to get as much operations out of the Viper rover as possible. I also remind you that it is a zero-sum game, and we are doing our best to maximize the science that we can get across the board.
Good, good. Thank you.
Yeah, thank you.
All the way down to microphone 1.
Tim McCoy from the Smithsonian Institution. Louise, I'm really happy you understand the power of these samples. Obviously, that's not been lost on me after 40 years of studying them. I spent today at Johnson Space Center talking to my curatorial colleagues, and I found it the kind of energetic thing that I always get out of going there. But it saddens me that my colleagues 40 miles away weren't able to come to this meeting. I realize it's been a very difficult year for federal employees. I am one of them. It's been very confusing, and there's been a lot of communication. But this is a world-class set of collections, the best set of astromaterial collections in the world. It is science-enabling, and for many of the people in the room, access to those samples, information about those samples is every bit as important as funding. And I really want to ask, and because I'm supposed to ask this in the form of a question, how do we correct this sort of communication breakdown or whatever caused this so that those people can join us at meetings like this in the future, because they are essential to what we do.
Yeah, thank you, Tim. I think a lot of us completely appreciate where you're coming from as far as attending conferences. It has been very challenging over the last few years, and I think it has got more challenging over the last year. And for those that don't know what Tim's alluding to, there is something called the NASA Conference Tracking System, where we are given a certain number of civil servants and a certain number of contractors that can attend each meeting. And so that number is set at NASA headquarters, and we can request additional numbers. I requested a certain number for each of the civil servants and the contractors for this meeting. What was somewhat disappointing to me was actually we didn't get as many people requesting to go. And I don't know if that's just become a self-fulfilling prophecy where people don't bother anymore. It's something that, we talk about it frequently. I mean, we spent a lot of time trying to get the numbers up. We do want to bring it up with the ninth floor, with the administrator. I think at this time there are a lot of other things going on. I don't think it's going to be a priority immediately, but certainly it's something that I do want to bring up. And yeah, I completely hear what you're saying. And I do want to especially acknowledge the great work that the curation team do. I think they are largely unsung heroes. So yeah, thank you to them.
Microphone number 2.
Hi, Rosalie Lopez from JPL. Hi, Louise. It's a question about the New Frontiers AO. You said in calendar year 2027, and you mentioned a community announcement. You didn't mention a draft AO, but I suppose that would come a few months before the actual AO?
I don't actually know. This is a Kurt Niebuhr question. I don't know whether we would release a draft or just go straight to the AO. I'm not sure. Sorry, I'm just looking at Charles. Do we always release a draft and then the final AO is 90 days later? That is the current. Okay, so we would release a draft, but I expect we will release a community announcement ahead of time as well. We'll certainly try, because there is so much uncertainty about what's going to be in there.
Yes, and
yeah.
that would be great. Thank you so much.
Thank you. Sorry for the uncertainty. I know, lots of uncertainty.
Paul Shank, microphone 3.
Hi,
Hi, Paul. How are you doing?
LPI. Great job again. Thank you again. I think, unless I was sleeping, you left something out, and that was Uranus orbiter probe and the 2 Venus selections for discovery. I'd like you to address those in the context of how the changes over the past year have affected PSD's ability to address the decadal survey generally.
Right. So the decadal survey, wonderful document, worked at the time it was released for the budget they thought they were going to have, and then we had a pandemic, right, and it came out just afterwards. So right now, the minibus bill that Congress passed does have up to $10 million to study Uranus orbiter and probe. It doesn't really say how. So we're looking at that, up to 10 million, and how best can we do that? There have been a lot of studies already. You know, we don't want to spend money on something that's already been done. As far as when that mission might actually happen, at the moment it's hard to see how it would fit into any sort of foreseeable budget profile at the moment. And part of that is, you know, we go, obviously our budget is year by year. We can make assumptions as to what the out years look like. But given that this year's budget is a couple of $100 million lower than where we were in 25, it's hard to see how we could start building a wedge for a flagship mission. Doesn't mean it won't happen. If it happens, it's likely to be towards the end of the decade. But at the moment, that's, you know, that's just, we're trying to get New Frontiers back in at the moment. As far as the Venus missions are going, hadn't forgotten. Might address your question too, Tracy. Trying to get ahead of the questions. So, as I mentioned about our priorities, things that are confirmed, Dragonfly, Near Surveyor, agency priorities, things that are in prime missions, instruments that have already been delivered to international partners. So we do want to keep discovery going, and we do care about having missions in phase B. So that's missions still in development that haven't been confirmed yet. Also mentioned, I think, mentioned it at AGU, mentioned it again here, it is going to be a challenge getting all 3 Venus missions to continue. Right now, Da Vinci was in the budget, right? It's mentioned in the minibus appropriation. Veritas, we are starting to ramp that one up slowly. We are still in negotiations with ESA about the future of Envision at this time. Just want to caveat again, nothing is final until the operating plan is in there. So we are doing our best by Venus, but it is a tough environment and not everything can move forward. So that's where we're at.
Okay, microphone number 2, Tracy.
Thank you. Tracy Gregg, University at Buffalo. Thanks for the Venus answers. But my question is related to one of NASA's goals remains inspiring the next generation of scientists. And it seems that student interns, particularly undergraduate internships, are a double bang for your buck. It helps to inspire the next generation. They aren't very expensive, and they help currently funded scientists to process data. So it benefits both the currently funded scientists and the next generation. I was wondering if you could speak to when or if canceled internship programs might be reinstated.
Okay, so I'm not, other than the LPI undergrad intern programs, I'm not super familiar with intern programs elsewhere across the agency. I'm looking at my team and no one is putting their hands up. Okay.
I'm specifically thinking about
Amanda might be able to answer. Yeah, so we, I will call in a moment, thanks Amanda, but just preface this by saying when we're looking at the budget, obviously we're having to make some tough decisions, right? But we are trying to maintain some support for students everywhere from high school all the way through, right? So that pipeline's really important. There's no point doing all these cool things if there's no one to staff them. So we are trying to maintain those all the way through. And I'm actually going to throw to Amanda to talk specifically about undergrad interns, if she can turn the mic on. How are you doing down there? Do you want to just pop up here? Sorry, I think we threw the IT people off. They weren't expecting us to use the mics. Good job.
Sorry, it's, I guess, what I learned from tracing my 3 children. Oh, yes, Amanda Nam, NASA headquarters. I wanted to tell everyone, if you didn't know, that we are running a relatively new program called Europa Icons, specifically targeted at undergraduate students. It's funded by Europa Clipper, and it is in partnership with OSTEM. We use STEM Gateway to advertise or to collect applications this year. We got 4,700 applications. I haven't actually calculated how many individuals that was, but we have 34 projects. So we'll be doing that. It's our third year. So it's not one that we brought back, but this is in its third year. But I did just want to mention that maybe you hadn't heard about the Europa Icons program that I'm particularly proud of for, it's a new-ish internship.
Thank you. I think that's very important to continue inspiring the undergraduates. I'm perhaps selfishly thinking of the previously known Planetary Geology and Geophysics undergraduate research program, PIGRP, and then it transmogrified into the summer undergraduate research program, SUPER. I suspect if I ask people to stand up, if you were ever a PIGRP or a SUPER intern, there's probably several. There we go. Thank you. I couldn't have asked for that to go better.
Yes.
So I just believe that internship programs are really important. They benefit both the scientist and the student, and removing them is kind of cutting off one's nose to spite one's face.
Yes.
Thank you.
Sorry, I can't answer that other report.
Microphone number 3.
Jared Longfox, University of Central Florida and Lunascope Survey. Thank you for all your hard work in guiding us through these difficult times. My question is, we keep seeing the different directorates, ESDMD, STMD, and SMD, call for understanding and measurements of the geotechnical properties of the regolith at various sites as a fundamentally enabling set of measurements for human and robotic exploration, yet none of the CLPS missions and none of the LTV deployed instruments are geotechnical payloads. So I was wondering where these actually stand in the priority list.
Sure, that's a really good question. I might argue slightly against your statement that none of them are. In particular, we have a large number of SCALPS deliveries which look at plume surface interactions, which of course has impact on whether we have just regolith consistency, et cetera, et cetera. So we've got 4 or so different ones. We've got a large number of payloads that are designed to scoop or take samples from the lunar regolith. That also tells us something about how hard it is to get through the regolith, and planet vac and sampler, things like that. So I wouldn't say we're not doing nothing. That's maybe the wrong number of negatives.
I completely agree. It's not nothing, but those are all opportunistic measurements. And my thing is kind of opportunistic measurements, and that's great.
Yeah.
But there are results that show we need dedicated payloads. Plume surface interactions are great, but there's not a geotechnical instrument slated to go to the moon right now.
That is correct. However, I would say that it is not at the bottom of the totem pole. I would say that we are looking at that in terms of as candidates for what we would. Let me phrase this appropriately. If we were to send crew out there, some of the things you might envision us doing is doing like a cone penetrometer, for example, and taking a look at what is that consistency, what is the geotechnical properties of the regolith. And so I will say that it is definitely in the hopper for things that we would like to look at in the long run. It's just a matter of budget, what can we afford right now, and when does it make sense for us to turn that development on so that we can have it in time for taking those observations.
Thank you for the detailed answer. I appreciate it.
Thank you.
Right. Microphone number 2.
Hi, Janie Radabaugh, Brigham Young University. This piggybacks a little bit off of what Tim Gouge discussed, and also, Louise, what you mentioned about asteroid Bennu and sample return. And that is, I'm sure you're aware that the Antarctic Search for Meteorites program has not returned to Antarctica except one time since COVID, because they've been left behind by NSF, who's in dire straits, I guess, right now, understandably. But you know, is a $500,000 or $1 million a year is still a really great bang for the buck of sample return when you get 1,000 samples back from around the solar system, including Mars and the Moon. And also, as you know, Mike Kelly is retired, and I actually haven't kept track of who is shepherding the program now, and should be talking to NSF saying that they should live up to their 3-agency agreement, or, as I've been saying, that we should just go it alone and try to make our own way down there. I don't know, which is difficult. It's better if we go through NSF. But at the very least, it's a really important program, and they're ready to go every year. So I guess my question is just, I don't know what to do at this point with NSF having troubles.
Yes. I'm going to ask Kathleen van der Kayden, who's our curation lead for the agency, to address that. Thank you.
Yeah, absolutely. Thanks for that question. We are working closely, actually, Tim McCoy, myself, and our colleague at NSF. We are the Meteorite Steering Group, and we are working on setting up plans for cadence of ANSMET. Particularly this past year, there were a variety of challenges, including the interagency transfer of funds that NASA has to send to NSF to enable that activity. We are hoping to be on the docket for this year, 2026, and we are working to renew our 3-agency agreement that actually expires in the summer of this year to continue that partnership. There is a huge benefit to working with NSF for all Antarctic research opportunities. They have a lot of the logistical support, they know the area, they have the contacts, and we also, for planetary science, is important to get those samples back to curation. It's also important that the community is studying newly returned meteorite samples and publishing on those samples and demonstrating why it is so important that we have a certain cadence, if it's yearly, if it's every other year. So just encourage that as well. Thank you.
Microphone number 2.
Hi, Melissa Rice, Western Washington University. We've had a lot of questions about samples, so I've got to ask about Mars sample return. I heard in the Associate Administrator's talk earlier today that Mars sample return as we know it is dead, but that the agency is still very interested in retrieving the samples that Perseverance has been collected. And I heard a glimmer of hope that there might be considerations for alternate paths forward. I was hoping you could elaborate on that.
Lindsay, do you want to speak to that? I'm going to call up Lindsay Hayes, who is our senior scientist for Mars for the SMD, certainly. Thank you.
Hi, Melissa. I think what Louise said is, I think at this point, what we have, right? Mars sample return as we know it has been terminated, has been canceled. We understand that Mars sample return is, as the decadal says, the top priority of science. And as you can continue to hear, the value of sample return is not something that we are underestimating in any way, shape, or form, right? It's clearly important for our understanding of Mars to be able to get these samples back. And Perseverance, as a rover, is so incredibly well equipped to get us the contextual information about those samples. So these are not samples that are, these are samples that we've collected a ton of scientific data in order to better understand what we're seeing there. So, as you heard from the Deputy Administrator, we're interested. We know the scientific value, at least we know what we think the scientific value is and the expected scientific value, which is probably even higher. And so, we are looking at that, and we're trying to understand what things will be happening going forward.
Well, thank you to all of you for keeping that ember alive in the ashes.
Microphone number 3.
Hi, Jamie Eisen, York University. I just have a question about, is there any talk of like a replacement for MAVEN?
So MAVEN is part of our, so first of all, MAVEN, we haven't officially said MAVEN is lost yet, right? It's not, we're still looking for it. MAVEN is part of our Mars Relay Network, so there are 3 other spacecraft in orbit around Mars also. So Odyssey, Mars Odyssey, Mars Reconnaissance Orbiter, and ESA's Trace Gas Orbiter. So those with MAVEN are part of our Mars Relay Network. We have known for a long time that, as I've talked about today, 2 of those spacecraft are over 2 decades old, right? So we know that they're not all going to last forever, and the agency is thinking about what is next for Mars, and there is language. Sorry, I'm losing the track of where. But yes, we are thinking about the next Mars telecommunication orbiter that would be put into orbit around Mars and would join that network, presumably. So yes, they're definitely thinking about it.
Cool. Thank you.
Okay, we're going to go to microphone number 2, and we seem to be reaching a natural end, so let's let this be the last speaker.
Have we got any online questions? No online questions?
I have not. The way it's set up
Quite
here, I do
online.
not see anything online.
Excellent.
And if there are, I can't find them.
Okay, well.
I apologize, but yeah. Anyway, number 2.
Quentin Vitale Hawkins, University of New Mexico. First and foremost, thank you guys for everything that you're doing, especially as somebody who's a grad student right now. You guys are trying to lay down the foundations for the future, and that's kind of the question that I have. So, the current NASA budget is 0.35% of the U.S. budget, and the last time those numbers, we're talking 1959, before we even put a human into space. And at the height of Project Apollo, we had 4.5%. And even during the International Space Station and its assembly, we were at 1%. And then everything that we've presented today is the result of at least 0.5%. So what is 0.35% sustainable for the future going forward? And if so, how is that going to be? And if not, what is kind of being done to keep that, to get that budget higher to what it used to be, so that one day I can stand here like Clive and Chip and look back on a career in planetary science and being proud of, furthering United States in space exploration.
So I'll try to be a ray of sunshine and say 0.35%, first of all, is a really good number, and we're going to do a lot of amazing things with that number. You heard from Louise the sheer number of missions that are ongoing. That was just a small fraction of the actual planetary fleet that's out there right now. The current budget supports what we're trying to do with Artemis, what we're doing with CLPS. We talked about Cadence for New Frontiers, and we talked a little bit about Discovery. Yes.
Okay.
Oh, sorry. And so, is it sustainable? I think it depends on what your definition of sustainable is, but I would argue that we are doing amazing things at the moment. And as a scientist, we will always take more, and we will do more with however little, much more we would get. But we are doing our very best, and I would argue that it's really good work that we're performing. Thanks to all of you. Yeah.
Thank you.
Thank you.
So Louise, the AV Tech just told me where the online comments were hiding. For those of you online trying, I apologize, and I see 2 here, and if you'll give me the leeway to ask those 2, and then we'll call it the night. First one is, will Artemis 3 have rideshare mission opportunities?
So let's see, is Jake Bleacher in the room? Did I see him running really fast when that question got asked? That is a great question. I don't think I have the answer to that right now. However, I would please tune in to that session I was talking about, the fireside chat with Lori Glaze on Wednesday in the late morning. I think that's a great question for ESDMD. Unless, Joel, you know any difference?
I think it's not defined yet.
Yeah.
Constructing the mission architecture, we don't know
Yeah.
yet.
It's not defined yet. We're still constructing the overall mission architecture, and so whether there's opportunities for secondaries or otherwise, I think it's still up in the air.
Okay, and the last one is from Bethany Ellman, and I'll read it in full rather than trying to paraphrase. Could you please comment on funding for Mars technology, future small missions, as per the December 2024 MEP plan, and solicitation of a science payload for the Mars Telecom Orbiter? It would be great to understand future Mars science opportunities in the Moon Mars plan.
So I can't speak to the solicitation of a science payload for Mars Telecom Orbiter. I think nothing's been decided yet on that. As far as Mars Future Technology goes, where's Erica? We do have plans. Would you like to come and speak to this? So Erica Montback is our technology lead for PSD, and she knows everything about technology. So she's kind of awesome. So you have a great team.
Thank you so much for that kind introduction, but I don't know if I know everything. So for Mars Technology, we do have a solicitation that we just put out in January for STRIDE, which was mentioned earlier. And going forward, we're certainly looking at other opportunities and capabilities that we want to enable. We're working through how that can fit into our current and future budgets. When we have more information that we can share with the community, we certainly will. We're also looking at future events where we can have a discussion specifically about Mars. So please keep your eyes open for that. We'll certainly be sharing that with the community as we get that information.
Okay, and this gentleman has been very patient, so you truly are going to be the last one. Nobody else go to mics because I'm not going to call on you, but you get the last word, or the last question. They get the last word.
Thanks. Richard Warwick from Lockheed Martin. Louise, thanks for the updates on New Frontiers. Is there anything else you're able to share with us about it? I'm specifically thinking cost cap, availability of RPSs, and when you anticipate you might be able to share the stuff you don't know today.
When might we be able to share it? I don't know how long it takes to put a community announcement out. I mean, we're waiting for the operating plan to be passed, and we don't know when that will happen, and I don't really want to speculate on that. I hope it's soon, but soon is all relative, of course. I would think, certainly, I think it's likely that by the end of this year we could get a community announcement out with some of those details, if not all of those details. I don't want to promise anything because I really don't know, but I mean, I can't see much point of releasing something in 27 if we haven't given you a heads up in 26 of what that would look like. So, yeah, we will certainly look. I think it wouldn't take us long to turn that around, but we do need to make some decisions, and they're all budget dependent. So, yeah, anyway, thank you.
Okay, let's thank Louise, Brad, and their team. And we'll call this to a close. Thank you.
Thank you. And if you asked the question and want a calendar, please come up and get one.
I don't